Okay, so now we would like to know what is the probability that the woman is heavier than the man. So let's just write down our probability question. And we're going to develop this probability question. The probability that the woman is heavier than the man. So how could I write that as an inequality here to start with? W greater than M. Does that make sense to everyone? The woman is heavier than the man. Yes? Is that a good way to say it? Okay. Now this isn't really conducive to solving because there's no numbers here. It's two variables. Okay? So in order to get the actual new variable, okay, we're going to have to define a new variable, but we can't define a new variable woman greater than man. Here's why not. Is woman greater than man a linear combination of woman and man? Linear is adding or subtracting or multiplying by a number. Is an inequality symbol one of those? No. So we need to change this, rearrange it so that it looks like a linear combination. It's this simple. Move every variable to the left. So if I move M over to the left using Algebra 1, how do I move a variable to the other side? Subtract it. Add or subtract. If it's positive, you subtract it. If it's negative, you add it. So I'm going to subtract M from both sides of this. So I'm actually finding the probability that woman minus man is greater than, what number will be left over here? 0. M minus M is what? 0. Okay. So this is the probability that I want to find, but my new random variable, what's my new random variable? Is W minus M a linear combination of men and women's weights? Is it adding, subtracting, yes. So our new random variable is women minus men. So now in order to answer this probability question, I need to find the mean of women minus men and the standard deviation of women minus men. I started that standard deviation because it caught people don't pay attention to the rules. So I want you to make sure you pay attention there. So the mean of women minus men, or the expected value of women minus men, would just be the difference in their weights. So what's a woman's weight? 165 minus 197. So the mean of women minus men, our new random variable, is what? 165 minus 197. Negative 32. Negative 32. Okay, my standard deviation is still 63.7. Yes, because variances, you take the variance and you add the variances. Even if you subtract, yes, even if you subtract. Variances always add. So it'll be the variance of women plus the variance of men, and then square root it. So that's still the same as it was above. It's still 63.7. It's the same thing we just did. So why do it again? All right, so my new random variable, women minus men, is approximately normally distributed with a mean of what? Negative 32 and a standard deviation of 63.7. Okay, so now I need to draw a picture of that so that I can calculate my probability. So I'll do that right here. So my mean is negative 32. I need your help. Get your calculators going and find the standard deviation labels. Negative 32 plus 63.7. Louder, please. 31.7. 31.7 plus 63.7 again. 95.4 plus 63.7 again. 159.1. Okay, on the other side, negative 32 minus 63.7. Negative 95.7. Subtract 63.7 again. Negative 159.4, and then subtract 63.7 again. Okay, negative 223.1, very good. Okay, so now that we have our normal distribution, we've defined our new variable, we drew a picture of it, now we can shade in whatever section we're talking about in our probability problem. We are finding the probability that men minus women, which this is a picture of, is greater than 0. So where's 0 on this? Tell me where 0 is. Above or below the mean? Above the mean, kind of about directly in the middle of that, isn't it? So that's where 0 is. And where am I going to shade? I have to be greater than 0. So which way do I shade? Above 0 or below? Above 0. That's the picture of the probability I'm looking for. That's the picture of the probability I'm looking for. That must go on every normal problem. So now, how do I actually calculate that? Very good. You can use your calculator, normal, CDF, and you type in your lower bound, comma, your upper bound, comma, your mean, comma, your standard deviation. Now, if your calculator has the commands, you don't type commas. So like if you're going to do second distribution, normal CDF is number 2. If it looks like this, you just type in the lower, the upper, you don't hit commas. But some people's calculator just gives like a command like this with a parenthesis, and that's when you use the commas. So what would be your lower bound? 0. Your 0 would be your lower bound. What's your upper bound? Infinity, 99999. What is my mean? Negative 32. And my standard deviation? 63.7. And then you calculate that, and it should be your and what did you get? 0.3077. And that looks very reasonable. This is somewhere within the first standard deviation. So, I mean, we know 50%'s gone. The first standard deviation has 30% in it, and half of that, so 15. So this is like 60, 70%. So, all right. So last one is still the same exact type of thing. We're just going to do it again. But this time, what's our probability question? Okay, so the sum of, who are they, their weights? If you were to select 3 men at random, so how would you write the sum of 3 men's weights? What would be that random variable? M plus M plus M. So the probability that M plus M plus M is at most, what mass symbol is at most? Less than or equal to 500? Okay. So that's the probability question I want to answer. What is my new random variable I need to define? Okay, well let's look for some consistency in the other problems that we just did. I need to define the sum of 2 weights, so I wrote M plus W. That was my new random, the probability of M plus W. So that was my new random variable. In the next one, I had men minus women. That was my new random variable. From, where's it coming from? The probability question? Isn't the random variable coming from the probability question? So what's my new random variable? Men plus men plus men. That's why we do the probability part first. That part is the new random variable that I need to find the mean and standard deviation of. So the mean of men plus men would just be the mean of men 3 times, right? What's the mean weight of a single man? 197 plus 197 plus 197, or 3 times 197. So what's my mean? So, what was it, 591, okay? And then the standard deviation of men plus men would be the variance of men plus the variance of men plus the variance of men. Variance is what? Standard deviation squared. And then after you do that, then to get the standard deviation, you square root it at the end. So what is the variance of men's weight? No, just the variance of one man's weight. 47 squared plus 47 squared plus 47 squared, square root, and you were just giving me the final answer, weren't you? So what is the standard deviation? 81, okay, 81.4. All right, so my new random variable, m plus m plus m, is approximately normally distributed with a mean of 591 and a standard deviation of 81.4. All right, so I don't have room to draw the whole picture on here, so I'm just going to go to another sheet of, well, I'll just slide this up a little bit and draw the picture down here. So the picture for this, if you could help out and get the standard deviation numbers, that would be great again. So this is 591 pounds. And you're adding, what are you adding to that to go above? 81.4. Okay? So when you add 81.4, what do you get? 672.4. You add 81 again. 81.4. 753.8. Good. Add 81.4 again. 835.2. And then we subtract, I've actually got those values. When we subtract, we get 509.6, 482.2, and 346.8. Okay, so now this is our men plus men plus men picture right here. Now, what number is it that we're concerned with on here? $500. We want to know the probability that this distribution right here, this distribution, this one right here, is less than or equal to 500. So 500 is like right here. Isn't that where 500 is? So there's 500. And we want to know less than that, so we're shading over here. Does that make sense? So now to calculate this, I can go normal, CDF, and what's my lower bound? Negative infinity, so negative and then like 4 nines. And then what's my upper bound? 500. What's my mean? 591. And my standard deviation? 81.4. And I should get something less than 16%. What do you get? Point what? 1317. 1317. That seems very reasonable.